Hey everyone, how are we doing? It is time for office hours. Who's all here? If you're in the chat, feel free to say hi. Sorry we didn't have morning office hours this morning. I was editing some videos, getting them ready for some introductory stuff, and I think I changed the lighting somehow. I feel brighter in here somehow. Let me work on that. Well, if you're in the chat, feel free to say hi. I feel like everything's a little bit brighter in here. The future's so bright. I need shades. If you're in the chat, let's see if people are here. We'll go to live chat. Let's see. Let me go to filters. Hey, Connor, what's up? Good to see you here. Throw out some points here in a second. That is not the red one. I need to go over here to camera green screen. You might not hear me for a moment. Watch this. Ready? I was saying that, Kyle. I was like, I don't think you can hear me. I was making a whole bunch of video adjustments. Basically, this morning I was editing a video for our major for business analytics, and so I was it was a rush order on it. You're muted. Good, we're back. What questions do people have? Mila, Kaya, Cassandra, what questions do you have? I'm over there muted on that screen over there, but what questions do you have? We have a new command in the chat if you didn't know. We'll start off some work in a second. Oh, I said hi plus Mubot. He doesn't know that one. We can say hi to Mubot, one of the coolest new things we added. I think we added that last class for 201. Zachary, good to see you here. It is time for questions. Brian's going to worry about his cameras here in a little bit. So if you have questions right now, feel free to ask. We can do some chapter 7. We can do some BAS 320. What questions do you have? And thank you so much, everybody. I'm so sorry we canceled. I'm canceled all hours this morning. Can you show how to make the residual by predicted plot? Yeah, Connor. Which are you wondering for the visualization? We've got some. Could you go over question 5 and 6 on the chapter 7 quiz? And which ones are those? Because the quiz changes around. Cancel your. When did? Oh, we said that. Yeah. That's more. Kaya, that is more prevalent than ever. Course Hero, not the best for courses. At least for our work. On the homework, yeah, let's take a look at that homework here to start. And then Connor, you were asking about the visualization. You bet. We'll do the visualization next year. Connor, thank you so much for swinging by. Let's do the homework to start right here. So we're going to start some chapter 7 homework. Mubot cracking us up. Number 5 and number 6. Okay. So we're getting number 5 and number 6. We're going to block the bot, hide user on channel. Okay, let's take a look. Let's mark this down in the video. Here's another question. I'm not sure if select menu impacts how I'm supposed to use the reactive. I'm supposed to use not. Ooh, you might need to message me that. Amelia, I'm not sure if the selection menu impacts how I'm using the reactive. Yeah, you might need to message me that. That's a big one. That's some good stuff, Amelia, right there. Good stuff. Do working on the Shiny app right there. I can tell. So that is a big question. Stat 201. I like it. I like big questions. Chapter 7, homework, question 5. Oh, you sent me an email this morning with the file. Nice, Mila. Thank you so much. It was a crazy morning. Haha, crazy morning. Let's go take a look. This is a big one. This is the SAT problem. Make sure I got everything open for this. Here we go. We're going to take a look at the SAT problem. Let's go take a look at it. Here we go. Now, the number one thing you need for the SAT problem is the Regression Solver Pro app right here that I've created. So we are using this because there's certain questions that are just a lot more work to solve if we do them by hand. So we're not here to solve problems by hand. We're here to get answers. So to get the answers and to figure out and explain them to people, we're going to go over here to the modules on our course page. So on your course page, make sure you're in the modules and then scroll down here to chapter 7. And in chapter 7, you will see the Regression Solver Pro. So that's what I'm currently using right here. It'll come in use later in this question, but make sure to go and grab that now. It's going to be super helpful for this question and for a lot of other questions. So the first question it asks us is we're looking at verbal and math scores. I'm going to need a ton of help on this question because this is a tough one. So when we look at this right here, how would we describe this? So how are you going to describe this relationship? Who knows in the chat? Just give me some words for it. How would you describe this? Well, it's got this right here. It's mainly this. I see a little bit of that. We need to talk about the strength. So the strength of it, the direction of it, the form of it, and the unusual features. Strength is how spread out it is. The form of it, the direction. Well, is it either linear or not linear? The form of it, is it linear or not linear? The direction, is it positive, negative, or does it not well described by either? And unusual features. What would people say? Just think of some words here to talk about this. So our goal right now is to think of words as positive, definitely positive. It's maybe moderately strong, right? It's got an outlier up there in the corner, so it's positive, moderately strong. It's got an outlier there in the corner, someone who made like a 300, 800 or so. So we need to say it is positive. So this is eliminated. Where's the negative ones? This is eliminated because it says negative. There's definitely an outlier, right? And then this says that they have lower. This would indicate a negative relationship right here. So it has to be this one because students who have higher verbal scores tend to have higher math scores. So they follow each other. That is what a positive relationship does. The next question says, are there any students who don't meet that pattern? And we see this one right here, that student, which if you trace down is about at a maybe 250 verbal. That is right. And they did get that 800 math. How do we know it's 800 math? Well, right here, that's their math score. Looking at this person right here, they're pretty far away, and that is definitely an outlier right there. So definitely an outlier. That is that person. Next, we have this. What is R? It doesn't tell us what R is, so I need someone to take a moment right here. Let's pause and make sure we know what R is. When we see R, we should think that is this. Who can explain to me what R is? I don't love the interpretations here. This is one of my least favorite questions, but we should know what R is. That's a big learning objective to know if we see R, R is this. Now, it's not R squared until we square it, and then it's a different idea. So R is what? What is R? R is known as this. Starts with a C. Who knows? We haven't thrown out many points today. What are we doing? It's correlation. Great job right there, Kaya. It is correlation. So what is this going to tell us right here? They give a bit of a different interpretation than I would. So someone who scores one standard deviation above the mean in verbal would be expected to score above in math. So it's kind of the positive relationship here again. And then last but not least, we see that they're squaring it. And this is a key thing. Now, this is how to interpret R squared. If we take correlation right here and square it, we get the value of R squared, which is the variability in Y explained by the variability in X. This is what we were practicing yesterday. So if we go look at our notes from yesterday, when we were doing interpretations of R squared, blank percent, and I usually say variation, blank percent of the variation in Y is explained by the variation in X. You get the same sort of sentence right here. Blank percent of the variability in Y is explained by the variability in X. Remember, verbal is on the X-axis, math is on the Y, so it is just the same as our saying 33.6% of the variation in math scores is explained by the variation in verbal. And these are synonyms. Variation and variability are just synonyms. So long as we haven't looked at it improperly, we got the right answer. Next, we see here, write the equation. Now, this is where you pause. Do not do this one by hand. This takes way more work to do by hand. We want to do this with the regression solver applet. This is going to be a huge help right here. Do not solve this by hand. It takes way longer to solve by hand than it would with the applet. We're going to get on the screen right here where we can input the numbers. So we're just making it nice and neat right here so we can see what we're going to work with. And I'll disappear in a moment, but we're just going to have right here everything we want and make our life nice and easy. So this is using the applet to solve it. And let's see what we first need to input. We first need to input the value of R, and it literally says it right there. Now I'm going to pause right here because it says standard deviation of the Y. Now the Y is math. Got to remember that Y is math. So can anyone tell me in the chat what the standard deviation of Y is for 100 points right here? What is the standard deviation of Y? Be very careful. If you put something in the wrong spot, it will not give you the right answers. So look at the screen. What is the standard deviation of Y? And Y is mathematics. So what is the standard deviation of Y? If we put one value in the wrong spot up here, it will give us the wrong answers. It's doing all the mathematics that we don't need to do by hand on the test, so why do them during a quiz? We can just use the app I created right here to solve it. So what is the standard deviation of the Y variable? What is that? Who knows? Standard deviation of the Y variable. So we have to read down here. Verbal had an average of this. Verbal had a standard deviation of this. Math had an average of this. Remember, math is a y variable. And there's a standard deviation. So what is it for 100 points? Who knows? We'll see what people say. Give it like 10 more seconds. Great job right there, Kaya. I think that's the right answer. Oh, wait. Oh, Kaya, I think you've grabbed the standard deviation of the x. Unless, so Kaya, don't worry. That's the standard deviation of the x right there. And maybe that's why a lot of people do that. This is the standard deviation of the y, and the y is math right here. So we need to grab 162.6. Maybe that's why a lot of people put in that number, because the first number for standard deviation is this, but that's the standard deviation of the x, because remember, verbal is on the x-axis. So verbal is the x variable right here. So that's going to be the standard deviation of the x variable. And maybe that explains why a lot of people, there's a mix-up. Now we need the mean of the x. Remember, math is the x variable. And, or no. See, I almost made a mistake right there. Verbal is the x variable. And then, oh yeah, so that's probably where, there's a lot of errors that occur on this problem. And for all I know, I might be putting in a number incorrectly. So now we have here, the intercept is 247.638. We're just going to take, can we copy paste that? I wish we could. 247.638. 247.638. And then last but not least, we need that final answer right here. It says to 3 decimals, 0.593. And so that should do it, hypothetically. Yay! I always get a little bit afraid. One typo, everything goes haywire. One typo, and it all explodes. So the number one way to solve this problem is you have to be very careful when entering in your numbers. Make sure you take the information here, be very careful, be like, okay, this is the verbal. Verbal is the x variable. It'll go into where the x slots are at. Then we have math being the y variable. You can see behind me here. So everything that says y, whether we're doing the standard deviation of the y variable or the mean of the y variable, just make sure they go in the right places and you will solve it accurately. Interpret the slope of the line. Now, I don't love their interpretations right here, but they're trying to not give away the numbers. So we'd say for each additional point in verbal, so for each additional point in verbal, we're down to these two answers. And then it basically wants you to know positive or negative slope. Not the best way for studying for the test with this question. We would say the interpretation should be for each additional point in verbal, the model predicts an increase of 0.593 points in math score. So you could get full points on the test by just inputting the value of B1 right here. And that's an important thing to know also, that the equation is y hat equals B0 plus B1, and B1 is the coefficient of the slope. So if you did input the value right there, that would be a correct answer on the test. Predict the math score of a student who scored 335 in verbal. Now what we need to do is we need to just put that in for what in the equation. Kaya, just one letter here for 100 points. We need to input that value of 335 in for what in the equation right here. So what do we need to input? Because we're going to make a prediction with this. So we need to get a y value, which is going to be the math score we're predicting. But we're going to input this value of 335 as what? I'll show you something really great. If you're worried about your math, now I would solve this. I would solve it, and we can do that right here, because the answer is, we're going to take that 335 and we're going to input for x right there, because the x is the x variable. So we're just going to go, great job right there, Kaya. 335 times this right here plus, and there's the answer. So, but I said there's an easy way for this, right? It says round to the nearest whole number. The easy way, whoa, I thought that said change answer. The easy way to do this is to go here to the solver and input a value of 335. And it actually shows you the answer. So it carries all your decimals, pretty much exactly what we see, but it's going to solve it for you. Oh, you could. So make sure, let me look. No, the intercept, I don't think the intercept should be negative for this. You can also visually check. It doesn't go to 0 here, but if you're solving this, there can be negative intercepts. If you're doing a different problem, there can be negative intercepts. So make sure every number is entered in the right way. Like check each number individually. Does that make sense, Kaya, right there? Check each number. Do you want me to go back and show you how to check each number? Would you like me to do that right here? We can do it. You're here working the question, so you get to direct the way this goes. If you're working the same problem as me, I don't think I've seen instances when this has a negative intercept. So I don't think you should have a negative intercept for this problem. Okay, let's check the numbers. Are you ready? So we're going to go here and we're going to look at this. We're going to check each number in the box to make sure you have each one in the right spot. So I'll do it nice and slow here, but make sure you have each number in the right spot. You ready? I'll make it a little bit bigger here so we can see it a little bit better. And here we go. I am on the director. You ready? Okay, so the first number right here to check will be your correlation. Make sure it's entered in as a decimal. Your correlation is the first number to enter in. Make sure it's in as a decimal. The second number right here, which is the standard deviation of y, can be found right here. This is your second number. The second number is this number right here. Make sure that number right here is this number right here. The next number, which should also be close to it, these should be close, 100-ish or something, is the standard deviation of the x variable, which is going to be right here. There's the standard deviation of the x variable. Make sure that is, these numbers are close-ish. That'll be a good check right there. But it should be the second number or in this output right here. We're currently talking about this is this number right here. So it's the second number, but it's this number in the output. The next one, the mean of x, is going to be this value right here. That's the mean of the x. So it's the first number you see in this whole series of numbers. And then last but not least, we have the final number here, which is the mean of the y values, which is this number right here. Did that fix it up, Kaya? Is it looking better? How's that looking, Kaya? Does that solve it and fix it and show it to give the right output? Because then you should have an intercept up here and a slope up here that should look more reasonable. How is it looking? If that doesn't work, you can tell me your numbers and I will input them. Maybe something happened or something changed, and so is everything right now? Does it show a number that's not negative? Has everything gone right here? Oh, you switched them around? Oh, and that caused that big of a problem? And so does it look correct now? I wonder if that'll do it. 558. It could. I mean, maybe there's a way. Awesome. Glad to hear that, Kai. Yeah, it's easy to switch around stuff. It's so easy. Just you have to be very careful. I've had a lot of people tell me it doesn't work, and I'll be like, just double check the numbers. Double check the numbers. So this question seems really, really tough. This is the one that usually people get stuck on. It is a little tough because there's multiple parts to it. So it says here that every year a student makes a perfect 1600. If you made a perfect 1600, what did you make on both sections of this SAT? If you make a perfect 1600, what did you make on both sections? If you make a perfect 1600, what did you make on both sections? To make a perfect 1600, what would you have to make on both sections of the SAT? So to make a perfect 1600 with two sections equally weighted, what would you have to make? You'd have to make a verbal score equal to 800 and a math score equal to 800. So does that make sense logically? Like if your total score is 1600 with two sections each with this, now these values are the actual score someone made. These are the actual, like this person actually made this. We are not looking for the actual, we are looking for the residual. And what's the residual of their math score? So we need to figure out how much we missed their prediction by. And you can actually get an estimate for this if you look at the equation or you look at the output. Where is our output? Here it is right here. So if you think about this, this person made a perfect 800. Tell me one thing you know about the residual you're looking for. What do you know for certain about the residual? This person made a perfect 1600. Tell me one thing you would know about the residual. Just tell me theoretically, looking at this right here, I know that the residual has to be this. Theoretically, we know the residual has to be what? Theoretically, the residual has to be this. So think about this region up here. Theoretically, the residual for this observation has to be what? Like just theory-wise, it's above the line. That's a hint. So since it's above the line, theoretically, it must be this. Like whenever we solve the mathematics here. Well, so the residual is going to be mathematically, if we view it visually, the residual looks like this. That is the residual. And that residual must be a positive number because the residual is going to be how much we miss by. And since the point is above the line, then the residual is going to be positive. Everything below the line would have a negative residual. Does that make sense, Kai, right there? Like anything below the line would have a negative residual because the point is below the line. So since it's above the line, we're just trying to figure out mathematically what is this distance. Now, what value did we just find? We know what? We know what about this individual right here? We know what value? We know one of the two values. So we know one of the two values currently. We know the person's what score. What value do we currently know? So we know one value for this person currently because they did score a 1600, which means they made an 800. So what do we actually know right now? Hint. What do we actually know? We actually know what they actually scored. Does that make sense? We know they made an 800. So Kaya, what is the only thing we're missing right here? I need to figure out what. What do I need to figure out the residual? Just look at it visually right there. Hopefully that helps. What do I need to figure out this residual? Like what will I need to solve for that will give me the extra value to figure out how far these two numbers are apart? I need to figure out how far this is away from that other spot. What other thing do I need right here? I need to figure out that distance right here, like that distance right here. This distance, which is right there, that distance is what I'm looking for. So what goes in this question mark right here? What is the question mark value I'm looking for? To be very specific, I'm looking for this. What's in the question mark value I'm looking for? Exactly, which is going to be the prediction, right? So the line gives predictions, right? So what do you think I should use to get that? I should probably use the equation, right? Great job, Kai, right there. I should use the equation because the line is, I'm going to use the equation of the line to make predictions from the line. So that's what we're doing right here is we're going to find out the predicted value, which is going to give us this blue value I've highlighted right here. And to do that, we're going to use the equation of the line. And so let's go take the equation of the line, bring it over to our worksheet all the way over. You want to come back, worksheet? And we'll go over here and we'll put in this. And then we're just going to plug into here times 800. Now, why times 800? Because that is the verbal score. Now it's times 800. So that is the verbal score someone had, which will allow us to get the predicted value. Now, the predicted value is not what we're looking for. That's just from the line. That's going to give us our predicted value from the line, as in we are finding the value currently on the red line right here. Oh, it's not a red line. And then we currently know the actual math score a person had up here. And then we want to solve for the residual, which is the difference. What's up, Troy? Good to see you, Troy. We're talking about a really tough question here with residuals and actuals and predicted values. So we're about to solve for the prediction from the line to get the line right there. And then we can solve for the residual, which is going to be the difference between the actual and the predicted. So let's go ahead and take a look at that. Here we are solving for the prediction from the line. So we're getting the prediction on the line. 800 times 593. Plus 247, well, 648. There we go right there. Oh, 722. So what will this be now? All we have to do is do actual minus predicted to get residual. Remember the equation that residual equals the actual minus the predicted, or in notation format that E equals actual is Y and predicted is, here, we'll do that in green again, I guess, is y hat, which you see over there. Oh my gosh. I don't know colors. And so with this right here, it's Kaya, exactly another 100 points Kaya. And we'll just carry the decimal. So Kaya is solving it out mathematically here for us. Kaya is showing us that we're doing the actual, which is 800. That's what they actually scored, minus. And then we will carry the decimals. And we will get the full answer, but 0.038. Kaya, that's exactly it. Actual minus predicted. Great work. Just finished up chapter 7. Yeah, great work right there, Troy. Chapter 7's a tough one. Great, Troy. Congratulations. One of the toughest chapters. Actual minus predicted right there, and that's the value of the residual. And do remember, this is a tough one, which shows a lot of conceptual knowledge, but understanding it. Watch us get it wrong. Good. I forgot to check decimals at the end. I was like, wait, I didn't check the decimals. Ooh, that's a tough one. That is a tough one. SAT question. Whew. Let's do the next one here. Then we're going to do some plots next. So here we go. Let's put a break in the video. Okay, that one. Ooh, that took 20 minutes. Ooh, that was a good question. I think, Kai, did you ask that one? That was really great. Let's go over here and do 2630. Okay, we're doing the next question. Really good homework questions right here. Question 6. I had to use Help Me Solve This. Oh, yeah. That's a tough one. You did not, but glad someone did. Well, thank you. Shout outs to whoever did. Let's do the next question right here. Let's do it. This one, I feel bad. I had a few people already email me because there's a mistake that's easy to make. Hey, Robbie, good to see you here. I was wondering if you could go over similar problems as the extra credit number 2. Which one's the extra credit number 2? Is that Terry's thing? Robbie, could you explain? And we could do that. Yeah, Terry, Robbie, let me know. And I could do that. Let me know. Tell me what you want me to show. Is it ANOVA table stuff? Is that the ANOVA table stuff, maybe? I heard some students were asking like about stuff like that. I can do some ANOVA table stuff if you want. We're doing visualization next, and then we could do ANOVA table if you want. Let me put this in the notes. Visualization number 6 or 5, something like that. And ANOVA table? ANOVA table? Maybe. BS320. Robbie, let me know, and we will do it. Thank you, Robbie, for being here. 100 points, Robbie. Well, let's make you a mod. Why not? Just going out on limbs here, adding mods. Okay. So what you immediately should notice about this data is, what do you think older cars sell for? If you look at the car data right here, what do you think older cars sell for? Older cars probably, if you look at the data, older cars sell for, so you see the car with 1-year-old, $13,000, cars with 13 years old. Older cars sell for what? And you can graph this if you want while you're doing this. Go create a for loop or loops that when knitted will create the lyrics to a song. Oh, well, see, I don't know if I can do that exactly. I could try to. Did Terry write that? That was a really interesting thing right there. That's interesting. It's an interesting question. What class is that? I didn't write that question. Let's copy it to the clipboard. That is an interesting question. I don't want to do it, but that's a cool, interesting question. We don't have to graph this if we can see the relationship, but it doesn't hurt to graph it. I don't think we have to do it for this one. We're going to go here to fit Y by X. We're going to see if the age of a car can explain its price in dollars. And you can see right here, there is a very strong, mostly linear, a little bit of a bend to it. We do have a lack of fit. Yeah, it's linear enough. Ooh, it's on the edge of it. So there's a mostly linear relationship. Yes, with Terry. I could talk some for loops here in a second if you want. I could try to then talk about that and talk about for loops and what they do, and that might help you without explicitly answering the question. Because I want, I don't want to do the extra credit for everyone and be like, oh, we're branding in a video. Go check out this video. I wanted to give some sort of help. So if you notice right here, we have a negative relationship. So tell me one thing you know about the correlation right now. And this is where the mistake happens, and it's super important. Exactly. Troy sees it right here. First time, didn't realize it was negative because when you square root r squared, and this is one of those teaching to the test moments. I know I'm not here to do all the work. This is also on the Canvas content. If someone repeats it in the chat, I'll give some points. Make sure you're listening. Whenever we take r squared, to find r, we must do 2 steps. We must, you're welcome, Robbie, right there. We'll do it in a moment. We must square root r squared and then look at the what of it. So whenever you take r squared and turn it back into r, you must square root r squared and then look at the what of it, which Troy is saying about right there. Troy has kind of answered it. This is on the Canvas content. It's on the test. So you can square r to get r squared, but then when you go back from r squared by square rooting it, which I'm about to do, I'm going to take r squared right here and square root it, and that is the answer. But then you must check the what of it, which we were doing just a moment ago. Once you square root r squared, the next step that you must do, which this is on Canvas content and on the test sometimes, we must square root and then look at the graph for the direction. Boom, right there, Troy, another home points. And Kaya right there, good work. On the Canvas content, on the test, once you square root r squared, you must then check to see if it's positive or negative. So that's a common error with this one. Unfortunately, it doesn't count if you get it wrong. Is it going to like that? Please say it's okay. Oh, wait. Oh, my gosh. No joke. I had my finger hovering over the button, and then something in my head said, wait. Whoo! I almost did it, even though I know it's negative. That's how easy it is to make that mistake. It happens. Don't make it. Had a student make a 98 on a test because they didn't put the negative sign. It happens. It's a very big difference. Negative versus positive correlation. Explain the mean of R squared in this context. That means 89.2% of the variation in the price of a car can be explained by age. Age counts for, I don't love the way of saying it like this, but this would be okay on the test. If you ever feel the graders are not fair, let me know. I do know pretty much every which way to say things. But remember, age is the explanatory variable. So age is explaining the variation in price. I usually like to say 89.2% of the variation in price is explained by age, or the variation in age. It's so easy, right? It's so easy to make these mistakes. And we get to the tough one. I think this is the one I don't love. Why doesn't the model explain 100% of the variation or variability? It is possible for real-world data to be perfect. That is just a flat-out wrong statement. So that's wrong. It is possible for real-world data to be perfect. There's not enough data points. That doesn't matter. A rock knows.
It doesn't matter.
Funny enough, many of these answers right here are, I really need to talk to Pearson about this. I've been saying that for years. This is going to be the answer. It's because there's other explanatory variables that account for the rest of the variation. So that's the best answer. It is the best answer. But there's also a mathematical reason that if two dealerships, like if you think about a line going through the data, I'll show you here visually. If you take a data set, and Troy, think about this, and Kai, think about this too. For a line to explain all the variation in the data, what would the line need to do? For a line to explain all the variation in the data, theoretically, what does a line need to do? To achieve an R squared, which is all the variation explained of 1, what would the line need to theoretically do? And I can show you the answer right here, as long as I drew it decently enough. What does the line need to do to achieve an R squared, which that's very close to? I'll see that. I know, but just pretend. Don't get too mad about that. This is not an R squared of 1 anymore. To achieve an R squared of 1, and the direction of the line wouldn't matter, the line would need to do what? To achieve an R squared of 1, which is 100% of the variation, Kai right there, perfect answer, the line needs to hit all the points. It needs to go through all the points. So there's a theoretical, have no residuals. That's a great high-level answer. I love all these answers. Great, perfect answers here. You can't have any residuals. You can't have any misses. And this relates to, Robbie, relates to 320 with residuals and misses and sums of squares. So there's no variation around the line. It's a perfect relationship. And it could be positive or negative. It wouldn't matter. Rock already said it today. It's just that all the points are on the line. So they do give an answer that, which I hate because it's theoretically correct, that different dealers ask different prices for cars at the same age. So it would have the same X, but a different Y. Theoretically, that is accurate. And that's why the model actually can't theoretically do it. Theoretically, it's impossible. But in terms of real world application, there's other variables at play right here, which is a good answer and goes into multiple regression. This is the best answer, but this is theoretically accurate, and real world data can be perfect, especially if you only have 2 data points. Anytime you have 2 data points and you can calculate regression, the shortest path between 2 points is a line. So real world data can achieve a R squared of 1 because real world data can be perfect, especially if you only have 2 data points. So one of my least favorite questions, but the best answer is there's other factors at play that would explain the remaining variation. Best answer, but the other answers were probably not written by a statistician. Okay, we're going to do some visualization. I don't know. I love the stats. I love the theory. I'm going to put a more chill song on. Here we go. That's the one I was looking for. Perfect. Might even try to get some new music this weekend. Who is excited for spring break? Anyone shout spring break? I'm having some fun this week. I accidentally knocked over my breakfast this morning. Then I went and got some more pancakes for lunch. I had a granola bar for breakfast. But who's excited for spring break? For the Canvas content, will give us the graphs to see the directions, or we have to graph it. It would give you information. I don't know if there's any similar to that. Should we do a little Canvas content, Troy? After I'm excited. Kaya says, "What are you doing, Kaya? What's the plans?" We could do a little Canvas content. I'm feeling a little crazy here. I don't think people have been asking for Canvas content lately. I'll do similar. Last one we did was chapter 5, right? We'll do some similar questions to Canvas content. Let's see. IT system. Ooh, let's see right now. And let's go to visualization number 5. Got the screen blanked. I'm not doing anything except for spring break because my husband will be at work. Yeah, that's awesome, Kai. That's awesome. What are you doing for spring break? I have jury duty the day after spring break, so let's hope that doesn't interfere with our classes. So the Monday after spring break, I'll probably send out a thing. I'll have an announcement ready to go at like 10 to say like I have jury duty. So if I get excused from jury duty, which is the goal, then that announcement won't auto send. But there will be an auto send announcement ready to go at 10 to say I have jury duty today. Unfortunately, I have posted a video of previous semester to watch. I'm going to have that ready to go in case I'm supposed to be there like 8:45 in the morning. And so I'm going to say to them, I teach in, about an hour. I know what if it's a big federal case? That's the fear. That's the fear that it's like, oh, you're on this trial for 2 months. It would go through my wedding then. That's what everyone says. That's what everyone says. Everyone's been saying the episode of New Girl. Do some Kevin's content, Troy, you bet. Everyone's been saying that to me. That's what multiple people have said is like, there's an episode of New Girl. And I'm like, oh no. Yeah. Oh my gosh. Okay. Let's go do this. Let's do canvas. Let's do the visualization. Okay. This is visualization number 5, regression. And I think the question was about residual plots. So there is a full video on this. I'm going to put it in the chat right here. Visuals or visual. There we go. Mubot will figure out which one of those two to use. It might be visual or visualizations or something. I can't remember which command I put in. I'm going to go grab the timestamp, stat 201. We're all just relaxing a little bit today. I'm going to go to the grocery store later tonight. Kai, I think that's a great plan right there. That's a good idea. Just relax, sleep in. Hopefully you and your husband have a great break and everything. But yeah, enjoy your time. That's great stuff right there. Good plans. Just pretending yes. Yeah, exactly. Well, I'm also going to mention that I'm for jury nullification. I don't know. I was reading up on stuff. People are watching this real quick. We talk about do the visualization here. I'll get the data downloaded. But jury nullifications basically, if you think someone shouldn't be on trial for something, the jury holds the power to nullify the whole process. I'm going to be on like some trial of some like crazy thing. And I'm going to be like, yeah, I can't nullify this jury. This is absolutely insane. Infograph project for another class. Yeah, of course. Troy, of course, send it to me. And if you're okay with me showing it, let me know because maybe we'll show it. So Kai, I learned a lot right here. I was so frustrated when I happened. Just pretend. Nice. Kai, thank you for your help. Because it'll be very disruptive to everything if I have to be on jury duty. The plan is I really don't want to be on it. I'm sorry. I told them, I was like, I will do it spring break. I called them and told them. I told them I will do it summer session 1. They said, we can't just pick you for that. And I was like, I will do it. I will be there all week. I will be there all summer session 1 if I have to. But anyways, let's re-timestamp those. Okay, are you ready? Here we go. Let's do visualization number 5. Do some output right here. Here we go. Time for it. Let's do it. Kind of, that's some good knowledge. Here we go with our data for the visualization on regression. Number 5 right here. Let's go look at the used car data. Great stuff. Open it up. Of course we want to. Woo! Always dislike how those things are all tiny right there. I'm going to make this look a little bit pretty. There we go. Making it look much better. Much better. All this good stuff right here. Look at that. Looks just beautiful, beautiful, beautiful. And so now that we have this looking good right here, we can actually do some analysis on it. Not required to do that, but let's do it. I'm going to use a different variable than the one you're using. Or do we only have? We have price, and we have year, and we have lot. Well, I might use a totally different data set. You'll be using this data set. You'll be taking a random sample of 200 plus the last 2 of your UTID. And you will be using the variable mileage as the predictor and price as the response. So if price is the response, is that the Y or the X? For those starting this out, if price is the response, is price the Y or the X? If price is the response, is price the Y or the X? I don't like calling things predictors. Response is what we're talking about, what we're interested in. So is response the Y variable? It says price is the response, the Y. Troy, great job right there. Price will be the response, which is the Y. I'm going to use a totally different data set because I don't want to quite do the exact same project. I'm using one of our stats1 data sets for this. We're talking specifically right now about the residual plots for this. So let's go make a regression right here. Make sure to take your random sample. Make sure to use your variables. I'm using a totally different thing. I am going to look at... Some of these are pretty crazy. Let's look at how much people spend on their pets based on their number of pets. Here is the plot. We haven't created our regression yet. And let's go here and look at a fit line. That is the red arrow right here to fit the line. And to get the residual plot, we have to go to the red arrow here and go to the plot residuals right there. So the only residual plot you need, is this one right here. There's a lot of problems with this. Does anyone notice any problems? Time on the clock, 100 points each problem. Lot of problems with this. Lot of problems. Some very apparent ones. And we would write these in sentences, so make sure to write these in sentences right here. Let's screenshot it. So a lot of problems I see I can talk about. What do you see? Lots of outliers. We got an outlier here of a person who has a pet expense of like $9,000, a very extreme residual. They're a bit of an outlier on the far side, but then we have very extreme residuals over here. That person has a very, very large residual. They're actually the most positive residual. So really, we've got a large group of outliers over here, an extremely low outlier down here. They spend way less than we would have thought. So really, there's 6 or 7 outliers. Big outlier right there. Yeah, and the biggest outlier, it's good to note the biggest outlier would be this individual. And if you want to get data on them, go and click them. You can actually go down here and click them. You can then talk about this person to say this person right here. This person has 4 pets and spends $20,000 a year. Maybe horses, right? That person has 4 pets and spends $20,000. That's a crazy outlier. Might be able to get the value of their residual. We could say, their residual is about $18,000. Notice they're spending about $18,000 more than we would expect them to spend. So that distance right there down to that line is about 18,000. And how do I know that? Well, I'm looking right here at this person. I'm tracing over. I could say they have a residual of about 18,000. Maybe alpacas? I like that right there. Who knows? This person's spending way less than we would expect them to spend. This person right here, we can click them right here. Go learn a little bit about them. They live with 33 pets and they only spend $3,000. Well, that's a good bit less than we would expect them to spend, meaning they have a negative residual, and the negative residual is about 5,000-ish. We could try to like do this right here and be like, boop. Yeah, it's about 5,000 something. So treating those pets like royalty, I know. Well, this person doesn't. This person has 33 pets and they're spending, I think it was $3,000. We'd probably expect them to spend about $8,000. We could actually figure out how much we'd expect them to pay. We don't have to do all this work, but we could take their 33 pets right here, times it by the coefficient of the slope. And we need to enter in the decimals. We would expect this person to pay, I said about 8,000-ish. We'd expect them to pay $8,700. Meanwhile, they pay $3,000, so actual $3,000 minus predicted, they have a residual of negative $5,732. And that means maybe chickens. Oh, good point. Good answers, Kai. And maybe chickens. Good, thinking about what does this data actually mean? And we want to try to understand it. So this is a pretty big problem right here. Probably one of the big things you want to mention with your residual plots is the outliers. Just understand how this works, that this person has a negative residual. These people have positive residuals. Kind of talk about those. But the other big issue with regression plots would be our last condition after QQ, straight enough, no outliers. And the last condition would be what? What is our last condition after QQ, straight enough, no outliers? I'll draw it here while we talk about this. Good review. We've got here QQ means whatever the variables are 2 quantitative variables. Straight enough means a straight line goes through the data. And no outliers means we don't want outliers. We don't want those in the relationship. We want a QQ, 2 quantitative variable, straight enough with no outliers. And the plot doesn't thicken. You can say plot thickens or plot doesn't thicken. I like to say plot does not thicken because we can then say, yeah, the plot does not thicken. I've taught it as plot thickens before. It's going to live with, squirrels? Oh man, squirrels are my favorite. One of my old nicknames, squirrel. So, because I like to climb trees. Who doesn't, though? So what does plot thickening look like? Well, this one is an example of plot not thickening. So this one has a plot not thickening. We could do that right here because it stays relatively, as we say, homoscedastic. Homoscedasticity is a fun word that just means same spread. Homo, same, scedastic, spread. So when you look at a plot like this on the left, it is homoscedastic, but it might not have a linear relationship. Around the parabola, the points stay relatively what? Now, this would not pass the straight enough. This doesn't have a straight line, but it would pass the plot not thickening. Because around the parabola, what? So that one is actually good. Let's put a check mark. This is actually good with plot thickening. So we'll put the color check mark wise. That one's actually good because around the parabola, what? And we would see this in the residual plot too. Around the parabola, it looks what? It's actually strength if you think about it. Around the parabola, what? It's like relatively the same thickness. Does that make sense? Like pretty much the same. Don't look too hard at it. You're like, start Brian's a little bit tighter. No, just don't look too hard at it. We give it a glance and then we say, it's pretty good. But this other one, while linear, would pass the linear condition, and it could get thinner or thicker. But this one over here, I'm trying to draw with extreme plot thickening. And now if you think about it, the bands around it get thicker, and this would be a change in strength of the relationship. So although it is linear, it does not pass the plot doesn't thicken. So we don't want the plot to get thicker. Now, if you make a residual plot, and I didn't tell you this tip last time, all you have to do to make a residual plot is take your line and make it flat. You could literally turn this graphic right there into a residual plot by just taking the graphic right here. And think about this. A residual plot is just your original graphic, but the line is what? A residual plot is just your original graphic, but the line is flat. Does that make sense right there, Troy and Kaya, to see that? Like, you can make something a residual plot by just taking the line and making it flat, and then anything on the line would have a residual of 0, and then the residual, like that's the line now, has a mean of 0, like the average is 0 right there. And then anything above the line has a positive residual, and it's just its distance down to the line, how far it is away. And anything below the line has a negative residual. All you do is just take your line and make it flat. If the line goes up or down. So this question on homework, yeah, a lot of similar stuff on homeworks. So a residual plot is just a plot of all your residuals. And if you make the line flat, then the line is a 0 residual. So the quickest way to get a residual plot, take your line, make it flat, and then it's just the distance away from line. Yep, exactly. Then you can just see positive or negative. If you look at these plots that we have, I think there's one in the notes. We'll go down to the residual plot. It's just going to be, we'll take the original graphic too. Let's go take the original plot of it right here. So here's the original plot in the notes that we're going over. And then if you go down to a residual plot, I think it's towards the end right here. That's a different residual plot. I'll give a residual plot of it. We'll go down to this one. Oh, there's a residual plot. It's got to be a different graphic, doesn't it? Let me go get the BK menu items. I thought we made a residual plot. Let me go grab those BK menu items. 2 seconds. I want to go get some BK menu items. We're going to go look at those BK menu items real quick. It's posted right here for us to see. Burger King menu items. I mean, come on. Now I just want to go get some Burger King, but I haven't had fast food in forever. So here's the Burger King menu items. Let's open it up. And we're looking at fat and protein. We're predicting fat from protein. So fat from protein. I want fat in grams, I believe. And there is our perfect little Squidward or Patrick Star plot that we were talking about in class. And we're going to fit our line to it. And then we're going to go right here and make a residual plot. And when we plot the residuals, you can see right here, look. Do you see the same pattern? We talked about Patrick Star in class, but if you look at this right here, let's take each picture side by side. BK menu items. Croissant, which, oh my gosh, don't get me started on some menu items. if you take a look at this right here, we're going to put them side by side. So there's the first one. And then we're going to grab the other plot. And what you should notice about this is all we had to do to make the residual plot is take the line and make the line what? There's the original plot, and there's the residual plot. So start connecting dots right here. Start understanding where the dots are at. If you look at the original plot and the residual plot, and you say, I've got like 3 points above the line right here. Well, wait a minute. There's the 3 points right there. I've got this region of 3 points down here. Wait, that's that region of 3 points there. I've got, this little cluster of a little leg or something over there. And that's that little cluster of a leg or something right there. You just take the line and you make it flat. And then anything on the line has a residual of 0, because that's what it means to have a residual of 0, is that you're on the line. So it's the same exact pattern. It's just the line is flat. And then over on the side, it says residual to calculate how far it is away. So hopefully this brings a little more of an understanding that a residual plot just calculates and shows you every single residual from the plot. It's the original plot of the data, but it's just flat, because then the line would be at 0 or 0 residual, and because everything's on it. It's not because it goes through 0 right there. It's because anything on the line has a residual of 0. Like that point basically has a residual of 0. Tiny little positive residual. But that's a really good review. I think we're doing the for loops next, right? So we're doing for loops, and we'll do some Canvas content. Okay, let's go back to the main screen. If you were asking about... I haven't heard this one today, I don't think. If you were asking about that question, let me know. Hopefully that answers it. And analyzing a residual plot with the outliers, with the straight enough. You can look at straight enough with it. Is that a scatter plot? Yep, a residual plot is a scatter plot. It's a special kind of scatter plot that looks at the residuals. It's a great answer right there, because it's two quantitative variables, the y being the miss of the model and the x being the, I think it's the predicted values. And then we look at the miss for each predicted value. And so residual plots are scatter plots, but they're not the original scatter plot. So to differentiate, we make a residual plot from a scatter plot. The residual plot will show us all the residuals from the original scatter plot. It's like an aggregate of it. So that's a great question, Troy. So residual plots are used to kind of assess how a model's doing. Yep. So residual plots are scatter plots, but they're not the original scatter plot. Good question, Troy. 100 points. Appreciate all the questions and all the practice we're getting right here. Yep. Just keep asking those questions. Anything you're thinking about. It is time for for loops. Let me see if I can... okay, let's go check it out. I'm going to write one of my favorite for loops here. So if you're here for for loop practice, BAS 320, for loop practice, 410, BAS 320, for loops practice. Let's go take a look at this. Here we go. Okay. So we're going to do some for loops practice right here. And with this for loops practice, we are going to come up with our own question. So how about we say, create a math table where we can write a 9 times table. Okay, so which sentences? So my nephew Tolliver, he's getting old enough to do mathematics. I got to watch out, because I always joked, like, I'm going to teach him mathematics, and now he's old enough because he's already learning, like, multiply and divide and all that stuff. But nowadays, one of these days, I'll be like, I should teach him calculus. And they'll be like, Brian, he's 30. You're 60. Ah! Actually, I guess it'd be in my mid-60s then. Ah! So anyways, we're going to write out some sentences for him. So the number one thing to do when writing a for loop is not to write a for loop. I know that sounds crazy. I told you we're going to write some for loops here, but we're going to start by not writing a for loop. So how does it look to not write a for loop? Let's do this. I'm going to do this following format. I'll show you why. It's because cat prints to the screen and paste allows me to put words together. If you just cat, you can't put additional arguments. So the reason I don't just use cat is because you can't. Apparently you can. So I don't know. Maybe I shouldn't now. Well, you don't have the sep. I'll be. Well, let's see something. Can I do this? Okay, well, I'll be. Okay, well, cat just prints to the screen. We could put inside of a paste and paste stuff together. But at this point, it looks like I may just need to use cat. Can I do the last thing I need to make it look cool? Well, let me try. Okay, I can. Well, I don't need to use cat paste then. I can just use cat. Cat just prints to the screen. That's what it does. It's not a capturable output. Like if you store this in as value, you can't store it. There's nothing stored. So it's important to know what your code is doing, that all it does is print to the screen. You can store a paste though. If this was paste, this would be stored as an object right there, and it has that stored. So you could capture and store a paste, but the cat is just used to print to the screen. Also notice that it doesn't put quotes around it, so I like it for that reason because I just want to display things to the screen. So let me show you what I'm doing right here. What am I doing with the cat? Well, I am doing a sentence right here that says hello, then it prints the value X, and then it starts a new line and prints the value X. I don't like that it does a slight indent on that. Let me see if it does it again. Because I think the cat paste doesn't. Let me remove this. I don't like that. So you see, I'm so particular. Oh, it's doing it anyways. Well, I guess it's going to do it the way it wants to do it. Oh, I know why. There we go. I don't think cat alone has a sep function, which is the separator. Okay. Maybe they've updated things since I last tried these things, but that answers that. Okay, so we don't need cat paste. Well, there you go. Sep is the value of separation used, so it's going to create the certain separation between each thing I do. That's what that argument does, is everywhere there's a separation or a comma, it changes it. Now, you might say, what does this have to do with for loops? I need to know the code I'm putting inside of a for loop and what it's going to do. All I need right here is the following. And let's explain why. I'm going to have a for loop right now that just prints the numbers 1 through 9. That's all my for loop's going to do. So when you write a for loop, you start by writing for. For is going to give you a snippet. A snippet can be used to get the basic structure of a for loop. We need 3 things right now. We need a variable, a vector, and a skeleton. So these are the 3 things we need. A tiny bit, Kaya, a tiny, tiny bit. I know some super user do. Tiny, tiny bit of Linux. Tiny bit, not too much. So we are going to now have a variable we need here, a vector, and a skeleton. Watch this. Let's go right here and say vector 1 through 9. Now, I think this will run, but it's really not going to do much of anything. That actually ran. As long as it's not breaking, we're good. But you notice, it actually created variable and stored 9L in it. 9L is a short for 9 integer format. It just says that it's an integer value and not stored as numeric. So you could type something like 120L, and that is the value of 120, but it's just being seen as an integer, which is a smaller way to store information, rather than something like this, which would be, if I check the class of this, that should be numeric, I believe, or maybe double. Numeric, it is double. I mean, it is numeric. It's probably double decimal precision. But we don't need to know all the extent of the code. We should just see what's going on, but we can talk about every little thing that's going on right here. So please ask questions if you have them. We need to know what the for loop's doing. We have a vector 1 through 9 right now that it's going through. What if we went right here and just said print variable? When the for loop runs, what it's going to do is it's going to take and store into variable. It's going to store into it 1, and then it's going to print the variable. Then it's going to store into it 2 and print the variable. Then it's going to store into it 3 and print the variable. Then it's going to store into it 4, then 5, then 6, then 7, then 8, then 9, and then print the variable. So if you watch what happens right here, when I run this, it prints 1 through 9. So it's just printing the vector as it goes through. It stores 1 into variable, prints variable. Stores 2 into variable, prints variable. And we could shorten this a little bit, or go right here and say go 11 through. I'll go backwards. There we go. Why not? Creates a backwards vector. Stores 11 into the variable, prints a variable. Stores 10 to variable, prints a variable. Stores 9 to variable, prints a variable. So the vector controls the numbers it goes through or the things it goes through. We can use it for other things. So what we'll do right here is we're going to take our code right here, and let's just drop it in here, and do cat and say variable. I'm going to change this to number, because I want to say these are the numbers, and let's do this. Similar output. We're doing it in little bits right here, little steps to make sure we get everything we want. But so don't do the whole thing at one time. We've got the basics right here. It is now just printing the numbers 11 through 9, going backwards, and we're good to go. But how about we did the following? Let's go back to 1 through 9 again. Good stuff. Make sure it works. And let's say print number times 9. Well, that didn't run the loop. That runs the loop. So what do we have now? We now have a vector of values of 1 times 9, 2 times 9, 3 times 9, because it goes through and it just loops through. It stores 1 into number, does the equation. Stores 2 into number, does the equation. But how about we say the following? Number, and then we say times 9 is that right there. I think that'll do it. Let's check it out. There you go. 1 times, let's do a space. So I didn't do a space right there. 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. Notice how we have everything we want right here. And I wonder if, can I do that? No. So now we got to do the sep thing. It'll make it look too complicated. Won't worry about that period. Looks fine. Cool. So with this right here, we have a sentence now. We've now created a sentence. 1 times 9 is this. 2 times 9 is 18. 3 times 9 is 27. What if? That's basically where we want to get to. It's a lot of interesting stuff you could do with this. Like with your song question. Think about how you could use it to write a song and all this crazy things right here. But what if we did the following? This is what's called a nested for loop. So I'm adding in a second value right here. I think we did it. There's every value. Starting off with 1 times 1 is 1, 2 times 1, 2 times 1 is 2, going all the way to 1 times 2, all the values right here going through. This is now a nested for loop. Pretty interesting. I don't know. Just keep nesting them and see what happens. But you could just keep nesting and do multiple numbers. But look at all the output we get for such little code. We've only written just barely any code. And yet we get all of this output right here. So this is the power of for loops. To the question about like, why would we ever use for loops? Just think about how much output we get for such little code. And you could literally just change this to 100. And this is a little bit crazy. We're going to get like a max output, or it's just going nuts. That's what we want. And so now it just did all the combinations of values times each other. And it's printed off the screen right here. But no, it did it. Oh, wow. Yep, it's so much the screen couldn't handle it. But that's why we use for loops, is we can manipulate and change this at any time. And yeah, I think this is great right here. Probably even better than a for loop with this would be, though, if we turn it into a function. If we take this as a function, which goes a little bit beyond 320, and put it in here to the return, there we go right there with the return, and we say number, and then number 2, we call this multiply. Now we can go here to multiply, and we can say 8 and 3, and it says 8 times 3 is this. On the visualization screenshot, you do need to know analysis. Do you have questions, Connor, on it? This would be a better utilization of that for loop. Like I probably wouldn't for loop it, but that code right there could be turned into a function, and then it answers for you the question like, what is this times this? I just put in here 2 inputs, and you can find out the value of anything. So I could, my nephew's always asking me math questions, but I could say, oh, 8 times 321 is this. It'll just tell you any answer right there. It'll tell you all of that right there. And you could do a bunch of ifs and have it subtract. And I do questions like that for 474. Do we need the analysis variance section? Oh, that's 201, right? Yeah, for 201, you do not need the analysis of variance. We talk about that in 320. You will not need the analysis of variance. Your screenshot for 201 should include, I see what you're saying. We're doing 320 here for a moment. It should include this. Doesn't need the lack of fit. Have you checked out? Let me send you this way. Keep asking those questions. Let me see. Oh my gosh. Have you checked out the visualization playlist? I probably haven't told people about that enough this semester. But in the visualization playlist, I walk through the examples and explain how to interpret output. Really good advice right there to use. It's not on here anyways. There's the visualization playlist. And oh my gosh, I went to... Here, wait. Oh,
to take a random sample and jump, you will first need to go to...
I can't see the video now. No, I mean the chat. Wait. There we go. So here it is right here. This is the random sample and the... But please ask questions if you have them. Here's the regression, and I believe I go through at the end and show the residual plot. Do I? There's the equation. Oh, maybe I don't show the residual plot. But I go through and I talk about those right there. I guess maybe I didn't talk about the residual plot. Good questions, Connor, about residual plot. Yeah, and I guess maybe don't show the screenshot either. Now, do you know about the new one, Troy? I got the chat back up now. Do you know about the new hi mubot command? I think you might have saw that yesterday. But we do have a new hi mubot command, and let's do some Canvas content here in a second. But that's the new hi mubot command. Let's go back to the main screen. It should work, but try hi mubot if you haven't. It's our new command, trying to get people to start on. A lot of people saying hi to mubot, so I figured I'd write a command for it, which would be pretty cool. But yeah, mubot. I'm gonna try looking into some more commands. If you got ideas, if you got suggestions, let me know. But he, I wish I could have him cycle through different things. Like he randomly selected from a vector of different possible things, like yo, hi, what's up. But yeah, that'd be pretty neat if I like had him do that, or maybe because you can't do it without a space. I mean, you can't put a space in a command. I don't like that. Well, let's take a look at a little Canvas content here. Canvas content, Tom. Stat 201, Canvas content. Canvas content, chapter 7 and 8. Wait, Canvas content number 6. Points. Someone say points. More points. Canvas content number 6 is... Oh, we already did number 6. What am I saying? It is 7 and 8. Until March 21st. Wow, that's forever away. These are all free songs from YouTube. So YouTube has a playlist of free songs that I can use without getting in trouble. Your Straya level, awesome. YouTube has a whole like playlist of songs that are copyright free, and I don't get in trouble for using them. So I use them all the time. Pint hype, let's go. I love it. That's from Miniterm, I believe. With some misspelled points, and we made the pint hype command. For each 1 unit increase in X, we expect Y to increase by B1 units on average. What is that the interpretation of? Ooh, gotta love that if you get that as a test question. For each 1 unit increase in X, we expect Y to increase or decrease by this amount is what? A little bit of notes on the screen here, but that says for each 1 unit increase in X, we expect Y to increase or decrease. Hey, Kayla, what's up? I think we're gonna do it on Wednesday. Thank you so much for asking about that, Kayla. It's been a crazy, crazy time. But no, we will do it on Wednesday. Thank you for asking. Those dudes get a lot of people use them. Really good stuff. Kayla is right. Kaya's right. Excuse me. Kaya's right is the slope. And if the correlation coefficient is this, what is R squared equal to? So how do we find R squared? So much positivity in the chat. How do we find R squared? Who knows how we'd get R squared? How do we get R squared? That's the correlation coefficient. And just so we know this, correlation coefficient is what? Correlation coefficient is R. Square R. So all we're going to do is take R and square it. So you just would square this value, and that gets you R squared. 0.5 times 0.5 is 25. Keep your decimals. It's 0.25. If a residual is 0... Oh my gosh, that's an interesting question. Oh, wait a minute. Wait, this should be pretty easy. This should be pretty easy right here. I don't think I've ever seen this version of it. I think it generates random numbers. I've never seen this version. But what does a residual of 0 mean? This is the easiest version we could get. What does a residual of 0 mean? I love this question. Oh, well, yeah, we could square and sum the residuals, but if a residual is 0, what does that mean? Troy, you're on the right track, because what does it mean if it has a residual of 0? If something has a residual of 0, it's where? So chi is, you're seeing it conceptually, then the predicted and the actual are the same because predicted. Well, the only way to get a residual of 0 is that there's no difference between the two values. So if there is no difference, the values would be the same. And so these two values are identical. So conceptually, it means the actual, it's boom, Kayla and everyone. Oh, it was, oh my gosh, I'm mixing up Kayla and Kaya right there. 100 points for mixing up names. Brian can't get names right. Okay, Kayla, you missed it. Some people got to Shreya level and they're really excited. They should see what level comes next. They're very excited. They're like, I'm at Shreya level right there. Shreya level is the new hype level. They might find out what level comes next, though. We definitely need more levels. I'm really glad people like the levels and get excited about them. So 19.2. Harris is going crazy today. Troy is at that rock star level right there. Keep it up, Troy. And so now we have find the predicted value. So the number one thing to do, Caleb might destroy the mystery in a good way. What we have right here are coefficients. So with this right here, I love it. I love people like it. So we need to write y hat equals b0 plus b1x. So we're going to take and plug in the numbers right here. And b0 is 12 plus b1 is 3 times x equals the y hat value right here. So did you pass the next level, Kayla? You might have just left the oof. Yeah, you just did. Wait, watch this. Wait, Kayla, watch this. I'll give him back. No one leave. Wait. Oh, wait. Don't leave. Don't ever do leave. I think that's what we do. I never do this command. We'll see if Mubot does it. Don't leave, though. Very bad if you leave right now. Maybe it didn't work. There's a way to minus points. Maybe I do minus viewers. Just don't leave, though. Brian, take it away the points. We'll see if that does it. We'll see if Mubot replies to that. Well, I forgot how to do it. I just don't do it. So is it minus points minus viewers? You're a hamster tier. Oh, there we go. Oh, did I just do it? I just did it. I'm losing my mind. All right, I haven't subtracted points, looks like. All right, so minus 500 points. There's a way to do it. I'll have to look up the Streamlab chatbot. I just don't take away points. I am hamster tier. So we're going to plug in the equation right here of 7. And let's plug in the 7 right here. And then we can solve it out. This one's not that bad. We got that. How are people feeling? Have people taken this Canvas content? Sorry if someone's watching this and is very distracted. I am too. There it is right there. We'll do the next one right here. If a residual is positive, what is larger? If a residual is positive, what was larger? So a residual that is positive would be in this region. So you might do it. I guess we've covered most of it. We covered a lot of it so far. If a residual is positive, what was larger? So the line gives the predictions. The point itself is the actual. So what would be larger if the residual is positive? As in we're in the positive residual zone, not the negative. And this is the 0 residual zone. The actual is larger if the residual. And this is, Kaya, drawings like these, great work there, Kaya. Drawings like these are really helpful, especially when you get to the test. Be like, okay, wait a minute. It's above the line. Great job right there, Kayla, too. And good practice for 320. We'll do another version of this because we're having some fun right here. So the actual will be larger. Submit our quiz. Unless I'm going crazy, we should get a 10 out of 10. Let's do another version. So if you want to work on this, you got some questions that I'm doing around here. But let's look at another version right here. If you know the R-squared value to the correlation coefficient, which of the following would you do? I'm not going to answer this question. I want you to answer this question with A, B, C, or D. We talked about this earlier. I said this could appear. I was giving those hints. The observation, good job there, Troy, for the last one. Yep, call it the observation or the actual. Both of those work. So we know the R squared value. To find the correlation coefficient, you would do which of the following? So we know R squared. And correlation is R. Correct, Kaya? Correct. But wait, there's more. You would square root it, but sometimes, I don't know if we have one on here, you would square root it. That is true. Very important. Oh, I can't know. So you would take the square root of it and then check the direction of the scatter plot. So good answers right there, everybody. 100 points. And graph it. Check the direction of the scatter plot. So make sure to look at the direction. This one would be a positive correlation. So you could find correlation from this by square rooting the value of R squared, and you would know it's a positive because the graph goes up. You could also check the coefficient of the slope. Slope will be positive if correlation is positive. Great work right there, everybody. Make sure to know that. Like I said, that can appear on the test. So we have right here, consider the jump output. What is the R squared? It was that point. I'll show where it's at again. 34 point. Oh, good interpretations. 34.41% of the variation in finished times is associated with or explained by the variation in somebody's age. Older people are slower. There's Brian. And the B1 is the slope. So we just need to grab the slope coefficient. It's actually here in the output, 2.43. And Kayla, I'm sure you've seen this. This is what it looks like when we do it in R. So really good practice for 201 to see this, that you have your estimate of the X coefficient. So 2.43, that is the slope coefficient. And then the intercept is 156 right there, also right there, B0. And remember, that is when X is equal to 0. And that's good to remember, that B0 is when X is equal to 0, which is not interpretable here. Let's do a quick practice right here. Can anyone interpret the intercept for me like it's your test? The intercept's the easy one. So we'll do this because this applies to both 320 and 474, or 320 and 201. Can anyone interpret the intercept for me like it's your test? Ooh, good questions right here. Pretend this is your test, and it says interpret the intercept. What does that 156 mean? So the intercept interpretation is when X is equal to 0, we expect Y to equal B0. So when X is equal to 0, we expect Y to equal B0. There it is on the screen right there, a little small handwriting to deal with. When X is equal to 0, we expect Y to equal B0. We'll think about what X is, and then say when X is equal to 0, we expect Y, which is finished time. So when X is equal to 0, we expect Y to equal B0. B0 is whatever the value is of B0. Remember, it's the first number, B0 plus B1X. So we say when X is equal to 0, that's not going to change, that's just constant. We expect Y, that's time, finished time, to equal B0. And then this is not logical for this one. This one's not logical. I'd throw a little bit on not logical. I'd say this is not logical. When age is 0, we expect finish time to be 156, might be seconds, something like that. Great job right there, Troy. And then probably sprinkle on, this doesn't sound logical because babies don't run races. Hate to tell you that. But babies aren't running races. Great job right there, Kayla. I think Scott, when age is equal to 0, we expect the finish time to be 156.527. This is logical because of the age being 0. When age is equal to 0, we expect finish time to be 156.527 on average. I like the on average right there, Kai. Good answer. And then sprinkle on a little bit. I don't think babies are running races. Or newborn. It's not even a baby. It's not even a 6-month baby. It's like somebody gives birth and that baby just runs that race right there. So I don't think this is happening. I don't think this is logical. If you notice, it really only goes down to about 20. This would be what we call an extrapolation of the model when you're outside the X bounds of the model. Chapter 8, extrapolation, is covered. So we got that one. Adding together all the residuals of a regression plot will always, it doesn't say that, but I'll add that, will always sum to 0 on average. Do all the residuals add up to 0? What are your thoughts? Residuals are how much we miss by. Some residuals are positive, some residuals are I was born to run. Baby Forrest Gump, maybe. Everyone else, no. True, 100% true. Some are positive, some are negative. The line of best fit goes through the center of the data. So by virtue of it being called the line of best fit, all the points would average together around it. Now, as Kayla knows, we can take these residuals and square them and then sum them and get the sum of the squared error, SSE. We talked about this a little bit way after the second class, but that would be the sum of the squared error. Since they add up to 0, like if you take positive and negative things and sum them together, the way these residuals work, or all residuals for lines of best fit, is that they just add up to 0. So we can find out a total error by squaring them, and then they're all positive, and then summing them to get a sum of the error, or squared error rather. And then we can root that to get a root mean squared error. If the correlation coefficient is this, we did this one earlier. Check out the solve that the correlation coefficient is r. We're trying to find r squared. And then we have an equation right here, b0 and b1. We can multiply, and this should be 19 because you're just multiplying x by b1, and that should do it. We solved that one a little bit more in depth, showing the equation to solve it. But overall, did anyone... What? Did I just solve that incorrectly? My sound is blooping. And my sound is blooping. I'm sorry, everyone. I'm sorry. I tried. I tried really hard. Failure. They even tried to warn me. It was like, you have not answered. Don't do it. Don't do it. You did not answer all the questions, Brian. You did not do it. I'm sorry. I'm sorry. I think you'll get it. I think you'll get it. I was like, what did I type in wrong? I did that one so quick. We talked about it conceptually. We talked about we should get those points. So remember to answer all the questions. Any last questions right here? We got 15 minutes before class. Let me send out the reminder. Afternoon class or late evening class starting up here in just a moment. But we will send out the announcement to them and say, hey, class starting here soon. Thank you so much, everyone who swung by. We'll be doing some more questions tomorrow. And yeah. Put a little music on here to end. I think Mebot just appeared by accident, or he's appearing now. We'll find out. I'm over here doing the music. Put on Despair. Despair's too sad. All right. Simple regression part 3. Class in 15 minutes. Okay. Grab a little food. Relax right here. Your kids are being awful. No! Tell them Stat 201 says don't be awful. Will we get the slope and intercept formulas on the exam? You won't need to solve for those, Troy. Good question. You won't solve the slope and intercept formulas on the exam. So that's why we use the regression solver. You won't need to solve the slope and intercept formulas on the exam. That's a little more mathy than we like. I know the campus content didn't seem so bad, right? You fail, so we win. I like that right there, Kaya. Well, that's got it. Let me know if you have questions. We'll be doing some more work tomorrow. Probably more chapter 7. Gotta get ready. Spring break's coming up. Not here yet. Hopefully we have a big attendance tonight. Let me throw out one last 100 points. People getting up to those Kaya Estrella levels, those Rockstar, those Hamster levels. We'll be back later. Bye for now, everyone. Bye. Class here in like 14 minutes.